Okay, let's try the last part of the parabola question. They want you to sketch the graphs of f and g on the same set of axes. Clearly indicate the intercepts with the axes and the turning points, any turning points. Well, first thing maybe it was good to sketch is just to take a look. We're going to sketch this. Well, let's sketch the parabola first. So we know that we're going to put a 1 over here for an x-intercept. This is the x line. I should write x in there. And here's the y, here's the y line. We should write that in there. Let's write the y line, y-axis in there. Let's put that in. It's good to label it so you can see what's going on. So x is 1, y is minus 4. We know that if we have x is 0, y is minus 12. So minus 12 must be right there. And way down here at minus 32, it doesn't have to be exact, and it's a bit out of proportion. This is a happy parabola. So I draw one that goes through here, hits the turning point, goes to minus 12 and 1. There's my parabola done. I write in axis of symmetry here at x equals minus 3/2. And way down here, it's negative 32 1/4, way down here. Well, there is the turning point labeled, the y-intercept, the x-intercept. There's the parabola done. Now, what about the line? Well, if we let x equals 0, y equals 1. This is the line g of x squared. So it goes through 0 and 1. But if we let y equals 0, what would you have to put in for x? Well, we'd have to put 1 in there, wouldn't we? Minus 1 plus 1 is 0. So 1 on the y, 1 on the x, and just connect them. And there's your line going straight through. Now, one of the intercepts is 1 and 0. But it's touching up here, and that's going to be the next question. They want to know about this point of intersection here. They want to know when the parabola equals the line. So that's what they say. Determine the coordinates of the intercept of f and g where x is negative. That means over on this left side, not this one over here, but this one. And how do you find out where f and g equal each other? You just take f and you make it equal g. That's your first step. Well, then you add x. 9x plus 1x is 10x. Minus 10 minus 1 is minus 13. Now this factors, it's a little tricky. You could put it in the quadratic formula and you'd get two different answers. Minus 13 over 3 or 1. But like 3x times x is the only way to get 3x squared. And 1 times 13 is the only even numbers or integers that could multiply. Hey, it works because 3 times minus 1 is minus 3. 13 times x is 13. 13 minus 3 gives me the 10x. Well, 13 over 3 and change the sign, that's the x coordinate of where they cross. Minus 13 over 3, and then what you'd have to do is take minus 13 over 3 and put it into g and add 1, and you'll get minus 10 over 3, the y-coordinate. So there's the coordinates of the intercept. You take this x value, put it into the line. I think I made a little mistake there, because if I put minus 13, it's going to become plus 13 over 3, isn't it? It's going to be plus. So when we take g of minus 13 over 3, I don't think we're going to get that one that I got right there. We're not going to get that. We're going to get something different. We're going to get 13, because we take a negative and we put it into a negative, it's going to be positive 13 over 3. And if we add 1 to that, which is 3 over 3, we're going to get 16 over 3. Which makes more sense because it should be positive. It can't be negative over there. It's a negative x value, but it's a positive y value, about 5 1/3. That's where it is, 16 over 3. Well, there you go. There's question 4.5.